So today we're going to work on more practice with graphing. If you would turn to page 24 in your notes packet, and I would like you to take notes on all the questions that we're doing in this video, so make sure that you put this into your notes packet. Okay, so again, this is just kind of review of last week. It says, part A, it says find the degree of the polynomial. So remember, we have two x's here, we've got another one here, and another one here. So that makes the degree of this polynomial for part A to be a degree 4, okay? So a 4th degree polynomial. Okay, let's find all the zeros of the function. Well, we know that we're going to have x equals -2. I'm just switching the signs. X equals 3. Oops, that's an x, by the way. And x equals -1. So there's your answer to part B. Okay, x equals -2, +3, and -1. Okay, now the end behavior of the function, I kind of like to save part C until after I have the graph. So let's go to part D and let's graph this. So we are going to, let me just put this in a different color. So we're going to have a 0 at -2. So let me do this. 1, 2, 3, 4. So that's -4. And then we've got 1, 2, 3, and there's +4. Okay? All right, so I've got a 0 at -2. So I've got a 0 right here. I've got a 0 at -1, and I have a 0 at +3. Okay. Now let's look at the fact that we have a negative leading coefficient with an even function. Okay, so what that means is, generally speaking, this is what our picture is going to look like. Okay, even if we have a negative leading coefficient, that means that we're going to open down like a frown. Okay, and we have 4 direction changes. 1, 2, 3, 4. Okay, so the other thing we need to take note of is that we have a squared term here. So that means our 0 at -2, we're going to have a bounce. Okay? All right, so let's keep all of that in mind. And lastly, what I would like to do is I would like to find the y-intercept. So remember, that's where we put 0 in for x. So I'm going to have a negative. I'm going to put 0 in for x. So that's going to give me what? 2, that quantity squared, times -3 times a +1. So then I'm going to have negative times 4 times -3. Okay, so that's going to be a +12. So I know that my y-intercept will be 0, 12. Now, I don't have enough room here, obviously, lucky me. So I think I only go up to 10. So we're going to fake this, okay? I'm just going to go like this, and I'm going to write next to this 0, 12, okay? All right, so I know I have to come from down below here, so I'm going to go like this, and I know that I have to bounce, and then I'm going to go like this, and then I'm going to go like that. All right, and there is my very ugly but accurate sketch. It's a sketch now, remind you. So 1 direction change, 2 direction changes, 3 direction changes, 4 direction changes. Okay? All right, so again, please make sure you're putting this into your notes packet. Pause me if you need to. Okay, next let's turn to page 26, and I'm looking at number 11. Now the reason why I'm looking at this one is not that it's any more difficult than the one on the previous page, but look at the way this is set up. It's not in factored form. So we are going to have to group and factor. So let's go back to Algebra 2. So that first grouping, I notice that they both have a term of x to the 4th. Please make sure you're taking notes. Okay, so I'm going to factor that x to the 4th out, and then I am going to end up with x minus 3. All right, then in the next grouping, I'm going to take out a negative. Why is my pen not working? There we go. Negative. And then I'm also going to take out an x squared. Okay, and then that's going to leave me with a positive x and a negative 3, which is what I want. If you recall, we want this and this to be the same. Okay, next I'm going to take my two GCFs, which was x to the fourth minus x squared, put them in one set of parentheses, and x minus 3, the repeats, in the other. Now that first set of parentheses that I have right here, I can factor. So I want to keep factoring until I'm completely factored. So I'm going to take an x squared out of that, x squared, sorry, and then I'm going to have x squared minus 1 left. And then I'm going to drop down that x minus 3. And if we weren't having enough fun, we're going to have a little more fun because that's dots. So I'm going to drop down that factor of x squared, and then I'm going to have x minus 1, x plus 1, and then x minus 3. Okay? All right. So now we're going to do the same thing that we did on the previous page. So we want to know the degree of this polynomial. So let's count. We've got 2, 3, 4, 5. Okay, so your answer to part A is it's a 5th degree polynomial function. Okay, let's find all the zeros. Well, here I have x equals 0. Here I have x equals 1. Here I have x equals negative 1. And here I have x equals positive 3. Ooh, I just realized on the last question I never answered the end behavior. Oops. All right, we'll do it on this one. And part D, we're going to sketch the graph. So let's sketch the graph first. I'm going to spread this out again like I did on the last one. Okay, so that we just get a slightly prettier graph. So that's going to be positive 4, 1, 2, make sure you're taking notes, 3, and negative 4. Okay. Alrighty, so let's get our zeros. So we have at x equals 0, so we don't have to find a y-intercept because there it is. Then we have x equals positive 1, we have x equals negative 1, and we have x equals positive 3. All right, so let's make a few other observations before we go any further. If we look at this, right, our Lie coefficient is positive. So since our Lie coefficient is positive and we have an odd degree function, 5 direction changes, then our picture is probably going to look something like 1, 2, 3, 4, 5, like that. Okay, now let's see if we have any bounces. And we should see that we have a bounce right here at x equals 0. So right here is where we're going to end up bouncing. Okay, all right, so let's go for it. Ready? Here we go. So I'm going to start from the bottom. I'm coming up. I'm going to hit this 0 and bounce off of it. I'm going to go like that. I don't know how high up you want to go. That's up to you. I'm going to go like this. Then I'm going to go like that. Okay, and there is my f of x. Alrighty, now let me go back to that end behavior. Okay, I'm going to try to squeeze it in down here. So as x goes to negative infinity, you can see that y also goes to negative infinity. Okay, just a reminder, remember what this is saying is look at the left-hand side of the graph, which is over here, and look, it's pointing down. Okay, all right, so let's do the other part. So as x goes to positive infinity, y will also go to positive infinity, because this is saying look at the right side of the graph. Here's the right side of the graph, and it's pointing up. So thus positive infinity. If you need to pause me to write any of this down, please do that. Get this in your notes. Alrighty, so now I am on page 29. But before that, I want you to take a quick second and turn to page 28. Pause me if you need to. And just read the first, we've done this in Algebra 2, so I'm going to go through this kind of quickly. The first sentence there, it says an even function is a function that is symmetrical to the y-axis. And then go down, halfway down the page, read that first sentence. An odd function is a function that's symmetrical to the origin. Remember an odd function, this is the way I described it. If you can take a picture and turn it upside down and it looks exactly the same as it does right side up, then it's odd. Okay? All right. So that's all we're going to do is we're going to look at these pictures and we're going to determine whether it's odd or it's even. Okay? All right, so let's look at the first question. Now, by the way, sometimes we have neither. So in this case, we have neither because if I fold along this y-axis, this piece here and this piece here, oh wait, I am wrong. Hold on a moment. Oops, excuse me. I am right. This would be a neither. Okay, they won't match up. So we've got a neither here. Okay, that's an I in there. Sorry about that. Okay, let's look at number 2. Now, if we fold along the y-axis here, okay, we definitely, this piece here is going to match up with that piece there. Okay, so since the left and the right side would fold onto one another, that will make this an even function. Okay, why don't you pause me and do the rest on this page and determine if it's odd or it's even. Now you should be able to do 7, 8, and 9 because you should kind of know what those graphs will look like. Okay, if not, hold on and I'll go over it. So pause me and work on this. Okay, and here are your answers. So hopefully this one should have been pretty easy. And this one as well. This is the one where you can turn it upside down and it looks the same upside down as it does right side up. Same thing here. Okay, this is a neither. If I rotate this, this piece right here ends up being down here, so that's not the same. And certainly if I fold this along the y-axis, the left and the right side don't match up. Okay, 3x squared, it's still a parabola, and its turning point is at the origin, so that makes that even. Now, x cubed, we did discuss this the other day. It kind of goes like this, but the -2, and we will discuss this, drops it down 2 units, which makes this a neither. And 3x plus 4, generally speaking, looks like this. That's also a neither. All right, so now if you go back again to page 28, you will see in the 2 boxes there are rules for even and there are rules for odd. Okay, so for example, the one box says that even would be f of x equals f of negative x. Okay, and then odd, you can read that one as well. So we're going to now use the rules to determine whether the function is odd or even, because we don't always have a picture, by the way. Granted, we could draw a picture of this one and we kind of know what it looks like and we can determine it, but it won't always be that easy. So we're going to start with something easy, to make it a little bit easier for you to figure this out. All right, so I usually always like to start with the even rule, which is f of x equals f of negative x. And the reason why I like to do that is I already have this, it's given to me. So I have to do f of negative x, and you've done this before in Algebra 2. Basically, it means wherever you see an x, you're going to put in a negative x, just like I just did. And then I'm going to keep going, and that is negative 10x plus 5. Now, do you see this? That's the rule for f of x equals f of negative x. And if I look at this and I look at this, they are not the same. Okay, so what you are going to write is f of x does not equal f of negative x. And I don't know if you know, but that's the symbol for therefore not even. Okay, make sure you're writing this in your notes. All right, so now I know the next rule is negative f of x equals f of negative x. That's the rule for odd. Well, I'm just going to rewrite the f of negative x down here, okay? And there's no reason to redo it. I already have it from up top there. So now I'm going to do negative f of x. Now just be a little careful with this one. It's not hard, but this means to negate the original function. Don't negate this. You're negating f of x. So I'm going up here, and I'm just going to negate that. And when I negate that, all that means, in this case, is to just make this a negative, since it's positive 10x up there, make that a negative 10x. And that's a positive 5, so I'm going to make that a negative 5. Now I'm going to group these two. And I notice that those are not the same, right? So I'm lazy. I don't want to rewrite this. So watch what I'm going to do. I'm just going to go, those are not equal, so therefore not, my gosh, my therefore does not look good, not odd. okay? And so then your answer is neither. Now, on a test, guess what? If anything that I have written here in black is not on your paper, you're not getting full credit. So you have to show all of your work, okay? Make sure you wrote this down. Alrighty, so we're going to do number 13 now. So I'm going to do the even rule, which means f of x equals f of negative x. So here I go. So I'm going to put in a negative x, square it, plus 3. Then I'm going to put in a negative x, square it, minus 2. Well, a negative x, if I square it, is x squared. And I just bring this down. And a negative x, if I square it in the denominator, is also x squared minus 2. Let's look at these two. Ooh, look at that. Okay, so I don't have room, so I'm just going to write it right down here. So f of x equals f of negative x, so you need to restate the rule. Therefore, even. Okay? All right. Now, let's do the same thing with number 14. Okay, so I'm going to start with the even rule. So I'm going to do f of negative x. So I've got 3 times negative x, that quantity squared, plus 8. And then in the denominator, negative x, that quantity cubed, minus 2. Okay, that's a parentheses. All righty, so let's see what we have here. So I've got a 3x squared in the top. And in the denominator, I have a negative x cubed minus 2. Okay, so let's look at these. Obviously, the denominators are not the same, right? So f of x does not equal f of, I'm trying to squeeze this in, I'm so sorry, negative x. Okay, so therefore, not even. Okay, so let's do the odd rule. So I'm just going to rewrite the f of negative x. So I know it's 3x squared plus 8. And I know I've got negative x cubed minus 2. All right, so now let me do the negative f of x. Now let's be a little careful here with this one, okay? So I did explain this last year. I'm sure Mrs. Paris explained it last year. When you're negating the function, and the function is a fraction, you cannot negate the entire numerator and the entire denominator, because that's a negative over a negative, which is a positive. So you have a choice here. You can negate the entire numerator and leave the denominator the same, or you can negate the entire denominator and leave the numerator the same. I'm going to do both just so you can see the difference between the two. Okay, so if I negated the numerator, I would have negative 3x squared minus 8, but then that would mean I have to leave the denominator alone. Okay, your other option would be to leave the numerator alone, so that'd be 3x squared plus 8, but change everything in the denominator, so negative x cubed plus 2. Okay, now, either way, let's look at what we have here. Those are not the same, okay? So we can say f of negative x does not equal negative f of x, okay? Therefore, not odd. Okay, which means then, don't forget, you gotta put the cherry on the top here. Final product, the answer is neither. All right, so now guys, your homework is to do the remainder, any problems we did not do, page 23, all the way through page 27. Okay, you can work together, it's not a problem, and I will be checking that tomorrow.